Hi everyone, my name is Elder Brian Angelo S. Ledesma from BE's ECE 3B. And this is my presentation on ECE 23 Performance Task number 8. So, the objective of this presentation is that by using binary machine in order to compute for entropy H or H, using probability method and using Hartley equation or Hartley function, and finding which method is more convenient to use. So here is the first example for binary machine number 1. So in this binary machine, we use ADEILMSY variable. So for case 1, it has 6 past questions. So for question 1, is it A or D? Answer is no. Is it E? Answer is no. Question 3, is it I? Answer is no. Question 4, is it M? Answer is no. Question 5, is it S? Answer is no. Question 6, is it Y? Answer is no. So, the answer for this binary machine is that letter L. So, there are 6 questions in total. So, 6 questions is equal to 6 bit. So, as we look on the binary machine, so we will use this variable first. For AD, we'll use A. So A, if yes, so A is predicted as 1. So if no, for AD, D is predicted as 0. Then, in this part, so we will use EILMSY. So for this variable, we'll use E. For yes, E is predicted, so it is 1. So for Y, Y is predicted as 0. So in this variable, we will use Y. So Y predicted as yes, so Y is 1. So for Y, predicted as 0 for S. So for this variable, we'll use again an S. So S predicted as yes. So S is predicted as 1. So for 0, we move to another variable, which is M. So M predicted as yes. So M is 1. And for 0, not predicted, so we will move to another variable, which is I. So I is predicted as 1. So it is yes. And for no, it is predicted as L. So L is the answer for this binary machine. So, in every level of this prediction, it has probabilities, which is for the first level it is 0.5. For the second, it is 0.25. For the third, it is 0.125. For the fourth, it is 0.0625. For the fifth, 0.3125. And for the sixth is level 0.15625. So, we will look for these probabilities of every variable. So for A, we look for A. So A is 0.25. For D, it is 0.25. For E, it is 0.25. And for I, it is 0.15625. For L, it's equals to 0.15625. For M, 0.3125. For S, 0.0625. For Y, 0.125. So, for number of bits, we will look for its line where it goes. So, for A, goes to 1 and 1. So, A is 1 number of bits. So, for D goes to 1 to 0. So, D is 1 to 0. And E is 0 to 1. For I, this is the I, so we look for 0, 0, 0, 0, 0, and 1. So, this is the number of bits of I. For L, so this is the equivalent bits of L. So, 0, 0, 0, 0, 0, 0. For M, this is the M, so we look for its bits 0, 0, 0, 0, 1. For S, so S is here. So it's SS 0001. For Y is 00, 1. So we will use for we'll use this calculation. It represents H as Hartley equation. So H is equals to 3 times 0.25 times 2. So 3 because it has 3 there are 3 0.25 in this binary machine. So 3 and 2 represents as the number of bits. 0.25 for its probabilities for every level. So 3 times 0.25 times 2 plus 1 times 0.25, 125 times 3 plus 0.0625 times 4 plus 1 times 0.3125 times 5 and plus 2 times 0.15625 times 6. 6 because there are 6 number of bits for I and L. So there are 0.15625 in their probability. So the answer is 5.7 bits. So we will use this equation for which is Hartley equation to find if it coincides for this first equation. So H equals to 3 times 0.25 log squared 0.25 plus 0.125 log squared times 0.125 plus 0.0625 log squared 0.625 plus 0.3125 log squared 0.3125 plus 2 times 0.15625 log squared and 0.15625, and the answer is 5.7, which coincide to this equation. So we will move for the another example. So here's the another example, which is different situation for binary machine. So for this equation or binary machine number 2. So case number 1. Question number 1. Is it A or D or E? So answer is no. Question 2. Is it I? Answer is no. Question 3. Is it M? Answer is no. Question 4. Is it S? Answer is no. And question 5. Is it Y? Answer is no. So the answer is L. The same as the equation in the first example. So there are 5 questions or equal to 5 bit. So this is less than case 4 for the example. So the first example has 6 questions. So the total is 5 questions equals to 5 bits. For its probabilities, we'll use same value, which is 0.25 and so on. And for the number of bits is this, or its where it goes, where it lined up for its number of bits. For A, so AD has 2 possible outcomes, which is 1 and 0. 1 is for yes and 0 is for no or false. For ADE, we will use A. So A is predicted as 1. So yes, A is 0.25. And for no or 0 outcome, 0 is equals to D. So in DA, we will use D. For D, if yes, so we see that it is 1. So yes, D is predicted. So for 0, so we predict E. So E is not predicted or 0 value, 0.125. For this line, we will use variable ILMSY. So we use Y. Y is predicted as Y. So it is represented by 1. And if not 0, we proceed to another variable, which is S. S is predicted as 1. So S is 0.125. And for 0 or not, we will use another variable which is m. So m is predicted as yes or 1. So m is represented. So for not, we'll use another variable which is I. So I is predicted as 1. So I is predicted. So and then for not, predicted as L. So L is the answer for this binary machine. So for its probability, so probability A is equals to 0.25 as we can see on this level. So first level is 0.25 and A is goes to 0.25, 0.5 for first level. So A is 0.25, D is 0.125, which is this is the D, and E is 0.125, and I 0.3125, L 0.3125, M 0.0625, S 0.125, and Y 0.25. So for its number of bits, we will look for its where it goes. So for A goes to 1 and 1. So number of bits is 1 1 or 2 number of bits. So for D, this is the D. So we look for where it goes. 1, 0, and 1. So 1 0 1. For A, 1 0 0. For E is 1 0 0. For I is, this is the I, so 0 0 0 0 1. For L is, here it's L 0 0 0 0 0. For M, here's the M is 0 0 0 1. For S, here's the S 0 0 1. For Y 0 1. This is the Y 0 1. So as we look for the equation, so there are two probability of that goes into for second level, which is 0.25. So A and Y is represented as 0.25. So there are two 0.25 and 2 number of bits, which is 1 and 1. So equals to 2. So the same process, or as we look on this, on its value. So 2 times 0.25 times 2 plus 3 times 0.125 times 3 and plus 1 times 0.0625 times 4 and plus 2 times 0.3125 times 5. So the answer is 5.5 in this equation, or 5.5 bits. So next is we will use Hartley equation or function. So H is equals to 2 times 0.25 log squared, 0.25 plus 3 times 0.125 log squared, 0.125 plus 0.0625 log squared, plus 0.0625 plus 2 times 0.3125 log squared plus 0.3125. So the answer is 5.5 bits, which coincide to this equation. So the more convenient ang equation that we use is this equation, which has less case or possible questions and less equation for each variable or every value of its for its equation, and less time to in making the binary machine. So that's the end of my presentation.